Welcome, everyone. Today we're going to talk about evolving agent complexity, and we're going to start simple but work our way up there to build a multi-agent system today. So first things first, this is our forward-looking statement, and also don't forget to complete your survey after this session. So my name is SJ. I am a machine learning engineer at Greenlight. I focus on the end-to-end machine learning and AI development all the way from model development to model deployment, as well as integration to our backend system so that we can surface the model to our users. And I also hold a master's degree in computer science from Stanford University and bachelor's in computer science from U of I.
My name's Tim. I'm the staff machine learning engineer and manager at Greenlight of all of the team you see before you. Work on all kinds of machine learning and Gen AI work, and previous to that, did a lot of data engineering and traditional data science. Graduate of Georgia Tech, go Jackets. So let me tell you a little bit about Greenlight. One, because it's a great product. Two, to give you context for our talk. Greenlight started off as the debit card for kids. It's a way to give your kids money that's not cash, because who uses cash anymore, to teach them to spend and save wisely. But since then, it's evolved into the #1 family finance and safety app. You can set chores and allowance on it to teach your kids how to earn money, how to be responsible with money. It has an invest section to teach kids how to learn about the stock market and learn to invest to grow long-term wealth. We also have safety tracking, where you can keep an eye on your kids, driving scores built into that, geo-fencing, all of that good stuff. And more recently, a new product called Family Shield that lets you monitor other members of your family's account. So maybe you have an elder parent or an adult dependent that you need to monitor their finances as well. You can do that with a new product, and you can just see a walkthrough of some of the features of the app in here.
All right, thank you so much, Tim, for walking us through what Greenlight is. And as you can probably see, Greenlight is a very complicated product where a lot of users might have a lot of questions about our products and features and all of our offerings. So today, we're going to build a multi-agent chatbot together. This chatbot will be able to handle all kinds of questions, including Greenlight features and products, customer service, and questions about investing concepts, and as well as spending and saving questions based on users' spending and saving data. And finally, we will have function calling, which we will talk about. Like one of the examples would be here is dispute a transaction based on the user's spending data. All right, so here's today's agenda. So first of all, we're going to give a quick recap over what is an AI agent. And then Tim here will walk us through the evolving complexity of AI agents, starting from a really simple prompt agent all the way to one that's capable of handling tool calls and everything else. And then I'm going to talk about multi-agent architectures, as well as Greenlight's multi-agent assistant that you guys just saw earlier. And then at the very end, Tim will put everything together into production, and we'll talk about evaluation and monitoring. All right, awesome. So what are AI agents? When we're talking about AI agents, it's very important to also talk about the difference between LLM and AI agents. So for example, AI agent is a goal-oriented system that is built around LLM. When we're talking about ChatGPT, for example, it's not an LLM. ChatGPT is in fact an agent. So when it comes to capacity, LLMs are only models that are trained on large text corpora, and it only has language understanding and generation. However, AI agents can have autonomous decision making. And as well as for the memory and state, LLMs are very stateless and has limited memory, while you can configure the AI agents to be holding long-term memory and doing long-term planning as well. The TLDR here is that LLMs are just brains. However, AI agents are the doers. They are built around LLM, and they control them and you can add tools and memory and autonomy. Here are some of the very common components that we will see when we're talking about AI agents. So obviously we have the brain here. Some of the very popular brains these days are GPT-4.1, Claude, etc. And obviously we can have prompts, which are basically instructions to tell the brain how to perform a certain task. And also we have data, whether this be a structured data or unstructured data. This kind of data will serve as the knowledge base or context for the AI agent. And lastly, we can have tools, which can be external or internal APIs. So here are, after we know all of the common components for AI agents, we still have a lot of decisions to make when it comes to the architecture for AI agents. There are so many questions we need to ask ourselves. For example, what is the purpose of the agent? What is the end goal? And what are we trying to do here? And obviously, what data does the agent need access to? Do we need to access structured data or unstructured data? And also, do we need to access tools? Will this be external APIs or internal APIs? And we also need to think about if we need to make multiple LLM calls or just one LLM call. And obviously, once we get the tool outputs, what are we doing with them? And at the very end, is this agent iterative or will this be a linear agent? And of course, there are very popular, very common tools that we're using for assembling the AI agents these days. The most common ones are LangChain, LangGraph, and Llama Index, for example. And so here, Tim will talk you through all of the complexity we have for AI agents.
Cool. Thanks, SJ. Yeah, like SJ said, we're going to start out really simple, but we'll get complex quick. And this is actually the flow we went through as we started building an AI agent or an AI product in our app. So step one is a very simple agent. This is what you would do in ChatGPT with a custom prompt. You define the prompt, give it instructions, how you want it to respond, what task you want it to do, and then you can reuse that without having to reprompt it every time. This is actually what we did. The very first idea of using AI in our app was to help kids understand investing better, help them convert investing terms and research stocks in terms they could understand. So it's a prompt like your helpful assistant, helping kids and teens learn about investing. Like, don't use any financial jargon without explaining it, and keep it relatable to them. So that was our very first agent a year and a half ago or more. It's called Invest Copilot. It's since evolved beyond just simple prompts, but this is actually how it started out. So you can see what's EPS, and we give them a kid-friendly answer to it. So then you move on to needing access to other data. So we want this in the app. We want kids to be able to invest, learn about investing with it, but we also need it to know about Greenlight. So that's where vector search comes in. We have unstructured data, public-facing help docs that we use the Mosaic vector store and vector index to ingest so that we can do contextual search so that now the chatbot can answer questions about how to invest in Greenlight. And I show all of this to talk about the complexity. It's not just the contextual search and the vector store. You have to have a pipeline for that. So it kind of all ties back to data engineering, feature engineering, whatever you want to call it. You have to have a pipeline to parse the data, embed it, and keep it up to date as well. Because we've changed, we've added new plans, we'll add new features. We want the chatbot, the AI assistant, to know about all of those. So here's an example of that. It's just referencing our public-facing help docs, and it can answer questions about Greenlight, like about what features are in a plan or what the cost of a plan is. So that was our Greenlight help bot, which was sub-agent number 2 of the Greenlight assistant. And then number 3, most organizations, probably every organization, has a wealth of structured data, because that, up until recently, is how most data was processed. You know, you've got reporting, you've got BI, you've got tons of structured data. How can we also get that into the agent? So we took advantage of the Mosaic feature store and feature serving to serve up some of our structured data, in particular our users' spend and save data, to help them learn about their spending and saving habits and find out how much they've been spending, where have they been spending the most, how can they be better about spending. So same thing here, you need a structured data pipeline or feature pipeline. We actually, in the current version of the feature store, we actually flatten this data into like a JSON representation per user or family, and then retrieve it at the time of the query or at the time of the question to the agent. And then the agent actually loads that into memory in a DuckDB instance and writes SQL against it. So here's an example of that. Where did Nico spend the most? Behind the scenes, it's retrieving the data from the feature serving endpoint very fast, and then it actually writes a fast query, or a query against DuckDB, which executes very fast, very small amount of data since it's isolated to that user or family. And then level 4, or what we got to next, was like, how do we let users take actions inside GL Assistant if they are figuring out how to do something and they're like, okay, can you do that for me? That's where tool usage or function calling comes in. So that can hook up to APIs, internal or external, can hook up to web search. You can hook it up to really anything. We wrote our functions and tools, explicitly wrote them ourselves for this case, but now there's a wealth of things in LangChain and other libraries that you can plug into pre-built tools already. So here's an example of that. It's plugging into our Greenlight chores microservice. So you can ask what chores does Nico have for this week? It's going to hit the API, retrieve the chores, and then answer it. And then you can also create chores, check off chores, and schedule new recurring chores as well. The thing we ran into with that, though, we still haven't actually expanded that to a lot of Greenlight functionality because it is a lot of writing custom code, both the JSON representations of the tools and the code to execute the tools. But then MCP comes along. So this is our next step. We've used it in some other apps, but not in this one actually. But there's a lot of pre-built tools now, so you don't have to manage these all yourselves. You can either use pre-built ones for external sources or databases, or you can write your own for your internal APIs once and then reuse them. So that's actually what we're in the process of doing. One of our engineers has already spun up a Greenlight MCP server, and we just need to fully test it out and get it all the way into production. So this is what you end up with. You can have an agent that has one or more of these components. It doesn't have to have all. And then I'll say the only thing not shown in here is the type of reasoning or the type of prompting you give the agent. This shows kind of a linear flow, but it could be a React agent that hits multiple of these and then decides if it is ready to respond, or it could be a linear, decide which chain to go down and execute those actions. Cool. Let SJ talk about our multi-agent architectures.
Yeah, thanks, Tim. So as you can see, there are so many different levels of difficulties when it comes to building AI agents. And fortunately, I guess, these days, many systems require more than just one single agent. So today we're going to talk about 3 core techniques that we're using for building multi-agent systems. The first thing, we're going to talk about the router-based agent, and then we're going to talk about meta agent, which is also known as agent of agents. And then lastly, we're gonna go through the supervisor and reviewer agent. So when it comes to router-based agent, you can think of it as a 2-layer architecture where the first layer is a router, and then it will route individual requests to specialized agents, and based on the classification rules that you specify in the router. And this kind of router-based agent is very linear, it's lightweight, and handles one-to-one tasks, which makes it very simple and fast and also predictable. However, the cons of this kind of architecture is that it's not very hard, it's pretty hard to scale with complexity and not super adaptive. So now we can look into an example router prompt that we have at Greenlight. Basically, you're telling the router what it does and also gives it options to choose from. And one of the use, kind of like hacks we're doing is that we're basically, sorry, this clicker is not working, basically adding few shot examples to help with the router classification performance. So now let's look at the agent of agents. Agent of agents architecture can be viewed as more than just two layers. It's basically a dynamic coordinator agent at the top of that router layer, and it could route to still numerous specialized agents. However, it can also select, composes, or spawns agents based on the context. So this kind of multi-agent system can call multiple agents at once instead of just one-to-one relationship compared to the router agent. And it's flexible and can handle really complex tasks. However, it can be way slower compared to the router-based agent. And then we have supervisor and reviewer agent. And supervisor and reviewer agent will review the answer that the specialized agents answer and then determines if we need to retry for a better performance. So the supervisor agent can act after the task execution, so it is another layer of quality control. And this kind of system improves the reliability and quality. However, it can also add latency because you don't exactly know if you're going to trigger retries or not. So those were the three type of core techniques that we have for multi-agent systems. And now I'm going to walk over Greenlight's multi-agent system. So here's the architecture that we have right now. Tim already walked us through all of the individual agents that we have in the earlier involving complexity slides. So obviously we have the function calling agent, which is hooked up to our internal services, and then it can handle questions such as, hey, can you help me create a chore for my kids, or how many chores do my kids have? And then we also have Invest Copilot, which is hooked up to external APIs that can answer questions such as how much is Tesla today, and what is EPS? And also we have customer support agent, which is hooked up to our internal knowledge base. And this customer service agent will be able to answer questions such as our Greenlight products and features. And lastly, we have the Spend Save Insights agent, which is hooked up to our structured data, which will have all of the user spending and savings data so that we can answer questions like, hey, how much have my kids spent in the past month? And here is another slide that basically shows an example of the Greenlight Assistant that we have using the multi-agent architecture that we just talked about. So right now, we can see that it can answer questions related to Tesla stock and as well as Greenlight's features. And this router-based multi-agent architecture has the 4 agents that we showed, and it also handles dispute transactions. So I want to also talk about why we chose using the router-based architecture instead of the other 2. The first thing is that we need expert sub-agents to handle simple tasks instead of using a giga agent that can handle everything together. Separating everything into individual agents makes it easier for us to build, tune, and debug. And also, we don't expect to handle really complex orchestration tasks because this is only a chat interface and we're not trying to do anything crazy. And very lastly, low latency is very important in a chat experience, and we don't want the user to wait a long time for us to generate the answers back. And also, obviously, similar to every kind of development projects, there are so many pain points that we went through, and I want to highlight some of them here. So the first thing is that it was really hard to change, well, not really hard, but it is definitely a chore for us to change the router prompt every single time when we want to add 1 or even more agents. And also, routers can really struggle with classifying a vague follow-up. This can be, I guess, improved if you're adding another layer of LLM inside that router to summarize all of the chat history and rephrase the question to make it a better follow-up question. However, that also adds latency. And also, we encounter several challenges when we're trying to surface streaming from agents back to the router agent. And so now that we kind of talked through the pain points that we have in the past, we also want to look forward to see what we're trying to do in the future when it comes to Greenlight Assistant. So the first thing we want to do is to add a supervisor layer so that we can ensure the answer consistency across all of our specialized agents to make it kid-friendly and easy to understand. And also we want to add more customer service actionable tool calling into our Greenlight Assistant so that we can handle more automations. And we also, this is tied to the second point, we basically want to add more tools and APIs into this Greenlight Assistant. And also, we don't want it to just be a simple chatbot. That is so 2024. We want it to be proactive so that we can generate insights for our users. So for example, instead of the user having to actively enter the chatbot and ask question, we generate spending and saving insights, such as here on the left-hand side, we're seeing Anthony spend this much less that week than the last week. And so we can generate this kind of insights by having a predefined set of questions sent over to our Greenlight Assistant and to display the answers into our system. And as well as having an invest insight as well. So instead of the users having to go into our chatbot asking questions about stocks, we can also have that kind of question already predefined and showing up in our invest page.
Cool, so now we've got our assistant. We've built it out, in our notebooks. It's deployed in Databricks, looks great. Maybe we've even got it integrated into the app at this point, but getting it into production and stable is, that's half of the problem still. So we're a small team, as I said. We've really relied heavily on Databricks, the Databricks platform, and the Mosaic AI tooling to help us do that. So inference tables, if you've deployed any serving endpoint on Databricks, you're probably aware of, logs all of the inputs and outputs for you. So everything is there. We need it for compliance because we work with kids and families and financial data, but we also use it for reporting. So everything's already in the inference tables. We can quickly build dashboards to monitor and report on the usage. This is one of the dashboards I look at almost every day to see how Greenlight Assistant is doing. And that's built directly on top of the inference tables. ML flow tracing was huge. Before this came along, the print statements, everywhere that the print statements had to go, and debugging an agent, especially a multi-agent agent, was very tedious. But this has been, a lifesaver. You can dig into every sub-process of your agent. You can see the inputs, outputs, and very importantly, you can see the latency. Where is it taking the longest? Because like SJ said, we wanted this to be low latency. We knew the barrier people are going to compare any chatbot against is ChatGPT. So we wanted to be as fast as possible, and this helped a lot in debugging that. But then how do we ensure that our agent does not go off the rails? Because like I said, we work with kids. This chatbot is primarily for kids, but also for their parents. The last thing we want is Greenlight to be in the news because our chatbot tells a kid something it shouldn't. So we use the Mosaic AI offline evaluation. It runs daily. We have a reference set that we continuously add to evaluate and make sure our agent is responding consistently and safely. We use the built-in judges. You can see relevance and safety are the built-in judges that Mosaic AI provides for us. And then this is a screenshot of two of our custom agent. One is to make sure the language is kid-friendly. We don't want anything too complex when we're talking about financial concepts. And two, very important for compliance, is we can't give anything that can be considered investment advice. So that is one of the agents, or custom LLM judges that we implemented as well. So like I said, this runs daily, and we get Slack notifications for it. So here's a screenshot of the Slack notifications we get each day, but we also use the online monitoring in the same way we use the offline evaluation. to evaluate our live inputs as they come in. So we're using built-in judges there, safety and relevance, as well as our custom judges. And some of these numbers are high. We really needed to tune the global guidelines here, but you can see it flagging kid friendliness on the left screenshot, and then the global guidelines, which is some of the relevance and like just how we expect the Greenlight assistant to ask. That's one of the only issues we ran into with the built-in custom judges, is they don't necessarily have the context of what your agent is supposed to be doing. So we took advantage of the global guidelines and regular guidelines for more granular control over how we wanted the agent to respond. And then it basically looks like this. Our architecture looks like this. At the top, we've got our agent workflow, all in Databricks. We take advantage of the notebooks, MLflow. We deploy on Mosaic AI, model serving, and we log to inference tables on our data pipeline, structured and unstructured. We pull data in from our data warehouse and other sources as well. Those notebooks are orchestrated in the workflows in Databricks, and they write to Delta tables in the feature store, and we serve those via API. And like I just went through on the right, we take advantage basically of everything we can in Databricks, agent evaluation, lakehouse monitoring, and dashboarding. And Mosaic AI Gateway has also been very powerful to us as well, because we don't have to change any of the code when a new model comes out. We use the models hosted by Databricks, the Claude models, the Llama models, as well as OpenAI and some models from Amazon Bedrock. And that's how we built our production-ready assistant. Skipped ahead a little bit, but we are hiring. We're a small team, but we are looking to expand. This presentation has mostly been about our user-facing chatbot, but we're working on a handful of other projects. Can't even read these. We have AI video generation for stocks to help kids learn about specific stocks and companies. We're doing personalized insights, which SJ showed for spending and saving and investing. We recently implemented suspicious transaction monitoring using AI. SJ has been focusing a lot on customer service automation. That's a big cost center, so we believe we can bring down cost through AI, and we get kind of bombarded all the time with internal requests for RAG chatbots or specialized assistants from accounting, marketing. So like I said, we're a small team, but we're looking to hire if you're interested. Happy to take questions, but also happy to connect as well. Thanks.
Thank you.